Hello students, welcome to KSMP Academy. Today in this video we will be looking at the derivation of the formula based on the dimension analysis and some of the examples. So let us have a look first at the deduction or derivation of the formula. So for this what we need to know the dependence of the physical quantity on the other quantities. Only then we can find out or we can deduce. Let us have a look at one of the example. What you are looking at is that we are given with the example of a simple pendulum. The time period of the simple pendulum is depending on length L, mass of the bob m, and acceleration due to gravity g. So with this knowledge we have to derive the expression for the time period using the method of dimensions. Remember, if in the question it is written that you have to use the method of dimensions, then we are going to use this method. So in the given question, time period is depending on what? On length, on acceleration due to gravity, and on the mass of the bob. So these are the three quantities. So that is what we are having. T is, you can write, is proportional to, let us say, L to the power x, G to the power y, and M to the power z. Or we can write T equal to K, L to the power x, G to the power y, and M to the power z. And this is what written here. And here K is a constant of proportionality. It may be having any value. So here we will have to do what? We have to find the values of x, y, and z. We have to find the values of x, y, and z. So with the knowledge of the dependence of the time period on these three quantities, that is length, mass, and gravity, we are going to find out the relation. So first, look at the left hand side, that is we are having T only. So dimensional formula on the left hand side of the time period means time, it is T to the power 1 or M0 L0 T1. So this is the dimensional formula of the time. On the right hand side we are having different quantities. So K is a constant, so it is a dimensionless quantity. So this is for length, that is L to the power x. For gravity, that is we are having acceleration due to gravity g, it is having Lt minus 2 to the power y. Similarly for m, mass of the bob, m to the power z. So let us solve it, simplify it. So we have this relation in terms of x, y, and z. So now we can compare both left hand side and right hand side, and what we get, that is x plus y equal to 0, and this is y, this is the power of L or dimension of length L. To the both side we are comparing. Similarly for the time we are comparing, that is giving us minus 2y equal to 1, and for mass it is giving us z equal to 0 if we compare the both side, both the formula on the left hand side and right hand side. So we are having two equations basically, x plus y equal to 0 and minus 2y equal to 1. So here what this is giving us y equal to minus 1/2, and we have x plus y equal to 0. So x is minus y, therefore x is 1/2. So we have x as 1/2, y as minus 1/2, and z as 0 by the comparison of the both sides. And what was the relation? We were having T is K Lx G Y Mz. So let us put the values here, and what we are getting is this formula, K square root L upon G, where K is a constant of proportionality. So with the help of the knowledge of the dependence of the physical quantity, what we have seen here, we are having a formula for the time period which is K square root L upon G. And you will look in the next chapters, that is this K is 1/2 pi, and that is the formula of time period of the simple pendulum, 1 by 2 pi square root L upon G. Another example related to this first unit. Let us look at here what we have to do in this question. So it is asking find the value of 60 joules per minute in a system that is having 100 gram, 100 centimeter and 1 minute as the base unit. That is, we are having two systems. So we have to find the unit in the second system. In the first unit we are given the unit. With the first system we are given the units. That is, this is first system. So here formula which we will be using is N1U1 equal to N2U2, where N1U1 is the one system, N2U2 is the second system. So that means N2 is the unit in second system and N1 in the first system. So from this formula we can write N2 as N1U1 upon N2, and assuming that this physical quantity which is given to us is having dimensions A, B and C. So this formula we can write. So if we know these values A, B, C and other values, then we can find the value of N1. So let us see, the given quantity is 60 joule per minute. So in MKS system we have to see that is 60 joule, it's okay, it is minute, so we have to write as 60 second, which is giving us the 1 watt. So it is basically power, it is 1 watt which is given in the SI unit. So this is one system that we have. So we have 1 watt. So what does it mean? N1 is 1 and U1 is watt. This is its unit. And for power we know the dimensional formula, which is ml square T minus 3. So looking at this formula, that is, if we compare with this, m to the power a, L to the power b and T to the power c. So here we have a equal to 1, b equal to 2 and c equal to minus 3. So ABC values we have. Now let's find the values of M1 L1 T1 and M2 L2 T2. So in SI units, in the first system, M1 is 1 kg, L1 is 1 meter and T1 is 1 second and unit is 1 watt. In second unit, if you look at the question, M2 is given as 100 gram, L2 as 100 centimeter and T2 as 1 minute. This is given. So we have to find N2. So let us substitute the values here and we will find N2. So N1 is 1 in first system, 1 kg, in second system 100 gram, 1 meter, 100 centimeter, 1 second and 1 minute. So let us solve it. So you look at here, again we have rewritten here. So 1 kg upon 100 gram, 1 meter upon 100 centimeter and 1 second upon 1 minute. So let us equate the units, that is 1000 upon 100, 100 centimeter upon 100 centimeter and then solve it. And if you solve, you will find this value, that is 2.16 into 10 to the power 6 units. So with this knowledge, we have now N2. So this can be written. So it should be clear that if we are having the base units and the dimensions, then we can convert the units from one system to another system. So remember what we have to do, we have to use this formula, N1U1 should be equal to N2U2 and ABC, that is dimensions, that we should know of the physical quantity. So this can be known from one of the systems in which the quantity is given, as we have seen here in the first system, that is, it was power. So dimensional formula for the power is known to us, so that we have used to find the value of A, B and C. Now next one is, by the method of dimensions we have to test the correctness of the given equation, and the given equation here is delta equal to mgl cube upon 4bd cube y. Now here delta is the depression in the middle of the bar, that is, if this is the bar and this is depressed like this, then this is delta. So it is in middle of bar, L is the length of the bar, D is depth where it is loaded with the mass M, and Y is the Young's modulus. So these are the quantities given to us. So look at the given equation. Left hand side is depression, that is distance only. So it is having L to the power 1, or simply we can write it is L. This way you can write. Right hand side, for every quantity we have to write the dimensional formula or dimensions. So first one is mass. So let us say this is M. Second one is G, that is acceleration due to gravity. So LT minus 2. Third is L cube. All the values are written here. 4 is constant. B is again distance. D cube, that is L cube. And Young's modulus, by memory we are writing, it is ml minus 1 t minus 2. And if we solve all these, then what we are getting is, this is L only. That is L. You can see here. So that means left hand side and right hand side both are equal, or dimensions are equal on left hand side and right hand side. So therefore we say that the given equation is correct. Given equation is correct. So given equation we can check with it. If we know the dimensions of all the given physical quantities, that can be checked. Example again, let us have a look. So this equation is known to us. This is known as the van der Waals equation. So in this equation what we have to do, we have to find the dimensions of A and B. And other quantities are having usual meanings, that is P is pressure, V is volume, and T is temperature, and R is gas constant. So with this knowledge we have to find the dimension. Now these two terms in the equation, that is P plus A upon V square and V minus P, these are multiplied. Now if we look at one bracket only, that is P plus A upon V square. So with the principle of homogeneity, we know that the quantities can be added only when they are having the same dimensions. So dimensionally we can see that A upon V square is equal to P, or we can write A is PV square. So dimension of P, ml minus 1 t minus 2, that is simply this way is also to write, that is ml t minus 2. This is volume. So for volume we have L cube, so it is squared. So it is giving you this value, that is m L5 t minus 2. So from this knowledge we have the dimension of A. This is for A. So with the principle of homogeneity we have seen the dimension of A. Now for volume again the same principle, that is V equal to B. So for volume we know it is L cube. So B is coming out to be L cube. So with this knowledge we can write the dimension of A is ml5 t minus 2 and dimension of B is L cube only. So with the principle of homogeneity we can find the dimensions also, which is clear with this example. So thank you very much students for being with us.